Quadratic equations. 2x squared equals x plus 3 is a quadratic equation because there is a squared term, or an x to the second power. There are three basic ways to solve a quadratic equation. You can use factoring, completing the square, or the quadratic formula. Factoring relies on the zero property. What is the zero property? If a times b equals 0, then we know something. Can you figure out what we know if a times b is equal to 0? Only 0 has this property in our number system. So this is kind of a handy idea, that if we multiply two things and we get 0, what do we know for sure? We know that either a equals 0, b equals 0, or both equal 0. Run that through your mind. A is equal to 0, because 0 times b would be 0, or b is equal to 0, because a times 0 is 0, or they're both 0, because 0 times 0 is equal to 0. Now, in order to use this principle, we need to set the equation equal to 0. Then we can either factor the equation or use the quadratic formula. So first, we're going to set it equal to 0 by subtracting x from both sides and 3. Now we get 2x squared minus x minus 3 equals 0. So we'll see if we can factor it. And then we're also going to use the quadratic formula. The completing the square, you should be able to complete the square, but we're not normally going to use that just to solve everyday problems, because factoring, if it works, is the quickest way, and if it doesn't work, then the quadratic formula will always work. Completing the square always works, but it's a little more complicated and drawn out process. So we're just going to use factoring method or the quadratic formula. So we first are able to factor 2x squared minus x minus 3 equals 0 into 2x minus 3 times the quantity x plus 1 equals 0. Now what does the 0 property tell us? That 2x minus 3 equals 0 would be a solution, and x plus 1 equals 0. That 1 is equal to 0, or the second one's equal to 0, or they're both equal to 0. So taking the 2x minus 3 equals 0, we first add 3 to both sides, and then we divide both sides by 2, and we get x equals 1.5. On the right-hand side, all we need to do is subtract 1 from both sides, so we get x equals a negative 1. So we have two solutions to this equation, 1.5 and a negative 1. Now let's see about how we would do it using the quadratic formula. Okay, we still have to set it equal to 0, and once it is, this implies that a is equal to 2, b is equal to a negative 1, and c is equal to negative 3 when you look at the general quadratic formula of ax squared plus bx plus c equals 0. Now, using the quadratic formula, which states that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, since we know what the a and the b and the c are, we just plug those into this formula. And then we evaluate it. We get x equals 1 plus or minus the square root of 25 over 4. And that would simplify down into either x equals 6 divided by 4, which is 1.5, or that you get x is equal to a negative 4 all over 4, which turns out to be a negative 1. Quadratic equations can have 0, 1, or 2 real or imaginary solutions. Now we will explore the second method, completing the square. Completing the square. Completing the square requires us to understand how to identify a perfect square trinomial. Perfect square numbers would be like 4, 16, and 25, since they all have a square root that is a whole number. Okay, these three equations are all perfect square trinomials. In other words, the x squared plus 6x plus 9, x squared plus 8x plus 16, and x squared minus 10x plus 25. And you can see where we got them. We actually squared binomials, so we're naturally going to get three perfect square trinomials from this. So now what we need to do is look for a pattern. Do you see that pattern that occurs in all three examples? The pattern is that if you take half the middle number and square it, you will get the last number. So let's check to see if that works. In x squared plus 6x plus 9, half the middle term is 3, squared is 9. So that worked. And in the second equation, x squared plus 8x plus 16, half the middle term is 4, and square 4 you get 16. And in the third case, half the middle is a negative 5, and you squared and you get 25. So the pattern holds, doesn't it, for all three cases. Now we will solve the following equation by completing the square. So first, is this a perfect square trinomial? No, since half the middle term is 2, and 2 squared is 4, and not a negative 5, this is not a perfect square trinomial. How can we make it a perfect square trinomial? By following the pattern that we established up above. We would need to take half the middle term, which is half of a negative 4, is a negative 2, and squared is 4. So we want to change the negative 5 into 4. Well, we just can't erase it. We have to use one of our axioms. Adding a plus 9 to both sides, let's see what that gives us. X squared minus 4x plus 4 equals 9. Now I'll check that trinomial out. If you divide the middle term by 2, you get a negative 2, and square that, you get 4. So the thing on the left must be a perfect square trinomial, and the 9 appears on the right. So we can factor it, and then we can rewrite x minus 2 times x minus 2 as x minus 2 squared equals 9. Then you can take the square root of both sides. You get x minus 2 equal plus or minus 3. And that means that x is equal to 2 plus 3, and x is equal to 2 minus 3. Two cases. Okay, first 2 plus 3 is 5, and 2 minus 3 is a negative 1. So this does have two solutions. In review, we have three methods to solve quadratic equations. They are 1. Factoring. This is the easiest method, but does not always work because you can't always factor trinomials. 2. Completing the square. This method also always works, but it's more complicated. And 3. Quadratic formula. This is the easiest method that always works. You have to do less thinking doing the quadratic formula, but you do have to be careful that you can work that formula out and perform the order of operations in the right way. The quadratic formula, ax squared plus bx plus c equals 0. So this is a general quadratic, and it implies, and we could figure it out, that x is going to be equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the quadratic formula itself can tell us a lot about the solutions or roots of the quadratic equation. If b squared minus 4ac equals 0, then there will only be one solution. If b squared minus 4ac is less than 0, then the solutions or roots will be imaginary, because that would give us a negative inside the square root. Also note that a can equal 0, since division by 0 is impossible. This also makes sense since if a equals 0, it would not be a quadratic equation. Special note, the quadratic formula was developed by completing the square on the general quadratic equation. It's within everybody's scope to understand that process, and for many of you to actually do it yourself. Okay, quadratic inequalities. X squared minus 5x is less than or equal to 14 is a second degree inequality. To solve the quadratic inequality, you first solve the equality to establish the boundaries. Then test each area to determine the solution set. So we're going to take x squared minus 4x equals 14. Subtract 14 from both sides. You get x squared minus 5x minus 14 equals 0. Then factoring, you get x plus 2 and x minus 7 equals 0. And now you can see in both cases we can just figure that out because it's pretty basic. If x is a negative 2 in the first case, a negative 2 plus 2 is 0, so that's one solution. And on the right, x equals 5, and if you put that back in, it makes 5 minus 5 is 0, and 0 times the 7 would be equal to 0. These are the boundaries of our answer. So we're going to put the negative 2 and the 5 on the number line, and since 0 is between negative 2 and 5, we will test that in the original inequality. So if we take x squared minus 4, x is less than or equal to 14, and if we put in a 0, we get that 0 is less than 14. Since this is true, the answer is all numbers between a negative 2 and 5, including a negative 2 and 5. So in summary, we could write it up algebraically as a negative 2 is less than or equal to x is less than or equal to 5. Or we can put it in interval form. And so we're going to use bracket, negative 2, comma, and 5, bracket. Now the reason we use these brackets instead of parentheses, it actually does work out better at this point. Or negative 2 to 5, and we should shade in the part that we say is the solution.